Writing and graphing inequalities. Lesson 13. So we're going to write some inequalities. Our I cans are I can graph inequalities on a number line, and I can write an inequality to represent a situation. So make sure you have today's date, your I cans, page number. Don't forget to put that in your table of contents, and you are ready to go. Let's do some estimation of heights of people. So take a look at the picture of the man here. What would be something that would be clearly too high for his height? Yeah, like 10 feet, 1,000 feet, 100 feet. What about clearly too low? 1 inch. It says in feet. 2 feet, 3 feet. So what about a height for this particular person? What seems like a reasonable height? Yeah, probably. If you go with like average heights of men in North America, then you're talking somewhere around, somewhere between 5 and 6 feet. So I'm gonna say, if I'm just gonna estimate in feet, looks like he'd probably be more than 5 feet based on using the chair here. I'd say probably closer to 6 feet. Well, actually, he's 5 feet 10 inches tall, so 6 feet wasn't too bad. What about here? We've got the same man, so we know that he's not quite 6 feet tall. Based on that, what can we say about the child here? Yeah, so the child is not half, is not half of his height, but his height is more than half, right? And you'd probably say the child is, if we were going to estimate the child's height, child would probably be somewhere around, 3 feet, probably not 4 feet, because if this is 6 feet, almost 6 feet here, maybe close to 4 feet. That does look like that could be about 2 feet of space there. So somewhere around 4 feet, but it's clearly somebody that that the height is less than the height of the child is definitely less than the man's height. Okay, and we're going to be using kind of more of that precision language as we talk further with this, instead of bigger or smaller or such. Oops. Okay, we would go through 4 different stories if we were in the classroom, but we are going to really just talk about one particular story. So Jada built a robot that pushes small boxes from one place to another. The robot is able to push up to 3 pounds. For a box, for what box weights can the robot push? Anything up to 3 pounds, right? So it could be 1 pound, could be 2 pounds. Obviously, we could put any sort of decimal with that, but 3 is the max, right? And it would be positive numbers here because we're talking about something that's actually pushing. Wouldn't have a negative weight when you're talking about an established item. Okay, so 1 pound, 2 pounds, 3 pounds, any of those would work. What about if we did it on a number line? What's it going to look like? Well, it's going to have, the 0, 1, 2, 3. And remember that we could talk about it being any of these, but we do know that it's able to push up to 3 pounds. So whatever that particular thing weighs, whatever the box weighs, it has to be somewhere from 3 pounds down less. It can't be something that's over 3 pounds. Okay? So writing an inequality, that's where we use our greater than, our less than, or our equal to. So it has to be something that's less than 3, right? So we can go ahead and plug in a letter because we don't know what it should be. Can it also equal 3 pounds? Yeah, so the weight could be, we could do, 3 pounds is equal to whatever the weight of the box is, or it can be also less than the 3 pounds. Oops. There we go. 3 pounds. Okay. All right, let's do a little bit further when we're talking about heights. Let's look at a basketball rim, a person, and then we have a ladder here. So estimate the minimum height of the basketball hoop to be what? Well, we've got a person standing here. It looks like that they are significantly shorter than the basketball rim. Let's say that there's lots of things you could put in here, right? The minimum height's got to be much more than she is. So I'm going to say that the minimum height is going to be 7 feet, and it can't be lower than this height, right? Or shorter. How do I know that? Well, given how tall that person is, even if it was the tallest player in the NBA ever, which was almost 8 feet tall, it still is, basketball rim is still taller than that. And if you're talking about, your average person being somewhere between 5 and 6 feet, for an adult, then probably that would make sense. As far as maximum height, well, if we take this person's height and then we kind of double on it, double on, if we say 6 feet max, 12 feet is a maximum. It means that the height cannot be taller than that. Because 12 feet is getting pretty far up there. And, when you think about, if you think about an NBA player being, on the tall side that's about 7 foot, they can just reach up. Well, if their arm, even if they've got a really long arm, they can still only reach so high. So 7 feet here for a minimum, 12 feet for a maximum makes sense. So the minimum height, we know that whatever it's going to be, we said, 7 feet? So if we say that 7 feet is the minimum, we know that it has to be greater than 7 feet. So 7 feet is less than the height of the basketball rim. We also figured out that 12 feet is going to be greater than the height of the basketball rim because we know that the height should be less than 12 feet. If we talk about on a number line, if we start this at 0, InstaSolve, based on the InstaSolve, if we were going to plot those, we know that it's going to be somewhere between the 7 and the 12 on a number line, right? Okay. If somebody estimated the height to be 19 feet, would that work as a possible maximum height? Some of you may have put that as a maximum height, but that would be like thinking, at least 3 of this person, even if this person was, let's say, 4 foot tall, which is relatively pretty short. Even if they were 4 feet tall, 3 stacked on top would be 12. Well, if you're saying that they're 6 feet tall, that's getting to 18 feet. So 19 feet seems awfully high. So is it possible to be a maximum height though? Yeah, sure. It could still be within the realm of possibility for a maximum height. Would it make sense for a minimum height? No, it wouldn't make sense for a minimum height because then that would be something that what you're saying is that it's at least 19 feet off the ground, which, even if we say that this person here is at least 4 feet tall, if we double that height, I mean, I think 8, 7, even 6 feet is within the realm of possibility, but 19 feet as a minimum height, it just doesn't make any sense. It could make sense as a maximum, but not a minimum. All right, let's do a little wrapping up here. What are 3 possible numbers that could be A if A is the absolute value is less than 5? Well, it could be a lot of things, right? It could be 4, it could be 3, it could be 2, it could be 1, it could be 0. Could it be -1? Or -2, or -3, or -4? What about -5? Well, it can't be -5 because -5, the absolute value of that is 5. So that's not going to work, right? But any of these other numbers, even the negatives, would work as well, right? Because -4, absolute value of it, is still less than 5, right? What about here? What about if B, the absolute value of B, is greater than 3? A lot of possibilities here, right? So it's got to be greater than 3. Well, 3 is here. So obviously we can do 4, we could do 5, 6, 7, 8, 9, 10. What about any of the negative numbers? Can we do any of the negative numbers? Yeah, because we're looking at absolute values, we can do -4, 5, -6, -7, all the negatives after or to the left of -3, because as an absolute value, they would be greater than 3, because in this situation we're talking about distance from 5, or from 0. So it's got to be more than 3 away, and that's why all of these numbers in here cannot work. So when you talk about maximum and minimum values, I mean, those are things that you're going to run into in a lot of different situations, right? You could run into maximum and minimum values when you talk about heights of like buildings, or, weights for elevators, heights to be able to walk through a certain door, minimum height requirements for like riding roller coasters. So those are things that you're going to see in all kinds of situations, and they can easily be graphed pretty quickly in several situations just to show all that inequality. But I think we have gotten everything we need, so hey, thanks for watching.